Thank you for joining us this afternoon. My name is Josh Joyner. I'm product manager of the ArcGIS GeoEvent Server, joined by my colleague on the team, Qingying Wu. We're going to be looking today at the ArcGIS GeoEvent Server and particularly visualizing real-time data. Look at some of the different ways that you're able to kind of take the data that's coming into the GeoEvent server and be able to kind of share that out through your web map and applications, so you can kind of share it out with your end users. Just as a real brief background on the capabilities of the ArcGIS GeoEvent Server, this product does bring the kind of real-time functionality to the ArcGIS Enterprise. It is a server role. There's 5 key capabilities that this product provides. The first is ingestion, so we're being able to kind of consume high volume, high velocity data from a variety of different sources. You can see some examples over here on the left-hand side. These can be moving assets, things like fleet monitoring, where you have a kind of a GPS device in a vehicle. You want to be able to kind of see where those are moving in real time. They can also be stationary sensors, things like weather station sensors, or things that are detecting things like lightning strikes, things like that. Any kind of data where it's continuously coming in at a continuous basis. So beyond simply bringing the data into the system, we also provide real-time analytics. So similar to our kind of geoprocessing tools in our desktop products, GeoEvent Server is able to provide analysis on the data while it's in transit. So you might be looking for, detecting a pattern of, I'm expecting a certain temperature value, and if I see values outside of that, what do I do? Well, these are the types of things you can configure kind of in the pipeline of data while it's flowing through. The third capability we provide is storage. Particularly when you're dealing with high volume, high velocity data that can accumulate over time. It does require some additional considerations in the storage quadrant kind of capacity. We provide, Esri provides our own big data storage solution. We call the Spatiotemporal Big Data Store. That provides not only a scalable storage solution, but it also helps provide some of what we're going to be looking at today. It allows for aggregation of features. So as we're trying to visualize kind of that high volume of data over time, instead of just simply looking at dots on a map, we can have it switched dynamically into an aggregated bin, showing us counts or statistics. Qingying's going to show some examples of that later on in a demo, so you can kind of see what it looks like in real time. We also can support live feature playback, live feature visualization through stream services. We're going to be looking at that as well. These are very lightweight, client-based applications that are designed to kind of allow for very smooth, very quick rendering client side for kind of particularly moving assets. That's really where stream services come into play at best. And the final capability we provide is dissemination and actuation. So beyond simply storing the data within the ArcGIS system, you can choose to send messages back out to devices in the edge. So I mentioned earlier, if we were detecting some sort of alerting condition, we could choose to show that on a map, or we could send out an email or a text message notification, or potentially even send kind of in the space of kind of the IoT space, we could maybe even send that actuation message back to some sort of device to turn off a system that's overheating, or activate some kind of redundant system in case of a system failure. So there's kind of 4 key areas we're going to take a look at today. We're going to kind of talk about kind of visualization, kind of the overview of what that looks like in terms of kind of working with real-time data. We're then going to break it into kind of 2 different areas. We're going to look specifically at stream layers. What are some of the benefits of using stream layers? What are some of the considerations for how you'd want to particularly render those types of feeds? We're then going to switch into looking at actual features. So, if you want data storage and you don't just want to show them in real time, what does that look like? What are some of your options? And finally, we're going to leave you with some resources. There's some sample applications we can share with you, as well as some additional kind of resources that can help you get started with some of this work. So we'll start with kind of an overview of kind of real-time visualization. The first method we're going to look at today in just a moment here is going to be stream services. And stream services are a component that's provided through the GeoEvent Server. They're exposed through the ArcGIS Enterprise, through the ArcGIS Server as a stream layer. This is a WebSocket-based kind of communication. It's a very lightweight form of communication that requires no storage, and it pushes directly from the GeoEvent Server to your client application. This can be a mobile application, a desktop app. It's a very, very efficient, very fast, very lightweight way of sending data. Unfortunately, there's no playback with that. So everything is stored within the actual session of your client. So if I'm looking at a web map and I see a bunch of features moving around and I reload that page, the previous observations are no longer there. It's only storing what's kind of received during that session. Kind of a more traditional way of visualization, and what most people that are familiar with ArcGIS Server are familiar with, is kind of a traditional kind of polling and visualization method. So data can be stored to an enterprise geodatabase through a feature service, and then those client applications can communicate over that RESTful interface over through the feature service or the map service. They can pull that data periodically. They can set a refresh interval in your web apps and web maps, how frequently you want to pull that, and have that kind of return to the client at a kind of a defined interval. Also using that same mechanism, we can also write through the Spatiotemporal big data store. This is, as I mentioned earlier, our kind of big data storage solution. From a client standpoint, this interacts the same as a traditional kind of relational feature service, but on the back end, it allows for kind of a much faster data throughput from GeoEvent Server. So if you're dealing with kind of high volume, really high velocity data that needs to be stored, this is really the best option for storing that. But it also can connect through the GeoAnalytics server. So let's say you've been collecting a large volume of data over time and you want to go back and be able to do some kind of larger batch analysis on that data. The GeoAnalytics server can communicate directly with that. You saw an example of that earlier this morning in Noah's presentation with GeoAnalytics that was kind of pulling data from the Spatiotemporal big data store. Typically, the GeoEvent server and GeoAnalytics server can be used in conjunction with each other. GeoEvent handling the real-time side and GeoAnalytics handling the big data side of this. So let's take a look now specifically at stream layers. So stream layers kind of at the highest level are really a visual tool only. They are very lightweight. I said there's no storage, which can make them very efficient for visualization because you're just drawing something on a map. There's no additional communication to write this to a database on the back end. It's only showing up in that client. They'll display almost immediately. I think in some of the tests that we've done, we're able to kind of visualize about 100 updates a second. Stream layers, I mean, actually, you know, that level of precision when moving. And so particularly if you're trying to visualize something that's moving in real time, let's say I'm monitoring a vehicle position, something like a stream layer is really, really efficient because you get really nice smooth visualization on your web maps. You can actually see a nice gradual transition. Unlike, say, a feature service where it's polling at a set interval, you might see the data kind of jump and then jump and jump as new updates are coming in. One thing to keep in mind is that the data is only sent to the client once, and if there's not a client listening, it does not get sent again. So, you know, the reason I kind of mention that is depending on how frequently your data is coming through, there could be an opportunity where you might open up a web map or web app and not see any data coming through because there was nothing there previously, and it will stay as an empty map until new data comes through, and that will kind of be visualized. But this is, again, a much more efficient way of doing it because instead of, you know, a feature layer that's having to do this like GET request and then getting a response, this is strictly GeoEvent pushing it via WebSocket directly to the stream layer and then out through the client. Now, using a stream layer is just like using a feature layer within your web maps. There's some additional visualization controls which we'll take a look at, but to add that layer to a web map. You can go and just like you would when you're pulling in a feature layer, you can do add layer from web, put the URL to your stream layer, drop it in and configure it. So we'll actually take a look at this so you guys can see what this looks like from a web map side. So what we have here is we have some flight data that's going to be coming in. So we can go and just copy the URL for the stream service. Click on add layer from web. We can paste in the box here and click add. And you notice as soon as we add it, the features start drawing at a very high rate. There are some additional controls for stream services. You can start and stop the streaming. So as you see, as soon as we stopped it, all the previous observations disappeared. You can also control which data you're going to be receiving through the web map. You can kind of scroll in, kind of zoom into the area of interest that you want. You can start your streaming and then choose this option here below, which is limit observations to the current map area. And what this is doing is it's actually kind of modifying the request going out to that WebSocket that we're subscribing to and basically saying, you know, I only want to see data that's in this defined geographic boundary. So this can kind of limit the amount of data that's having to be sent, even though this is already a very lightweight, client, very lightweight way of visualizing data. It can further reduce what you're sending. Like a feature service, you can also come in and adjust the renderers. Now there is one limitation with stream services that you can only choose one renderer for all of the features through a traditional web map. However, you can choose to rotate the symbology, rotate the symbols. So in this case, I have a heading field. So I can, if I'm using an arrow, I can choose to have it align with my heading field. So you can see the arrows kind of align with the direction. You can also choose to show previous observations if you've been collecting data over time. This can be a different symbol. So if you want to make like a smaller arrow, you could do that. You can also adjust overall transparency of the layer as well. But your actual controls of that renderer are pretty limited. It's pretty much one renderer per stream layer. So we're going to save this map. And then we're going to come back to it in a second part of a demo in a moment and show how we would share this out actually through an application. So if you wanted to then take that same data that we just put into a web map and you wanted to share that through an application, such as in this case, we're going to look at the web app builder. You can, from the map viewer, you can click share, create a web app, or you can also go from your My Contents. So if you actually go back to that stream item in your your contents, you can create the app using the web app builder, and you can provide the bounding box for that application. So we'll take a look at what this looks like within the web app builder as well. So we take the map where we just finished, and we can click share, create a web app. And there are some pre-built applications where we're going to pick the web app builder. And we'll give it a name so we can create a portal item. And within the web app, we can also enable those same controls that we had when we were looking at the web map, where you could choose to define a given area and a given extent that we want to consume the data from. We can also start and stop the feed. There is a specific widget for stream control. If you scroll down, it's based here in the top bottom left corner. This is the stream widget. Now, when you first open up the stream widget, you have to choose which options you want. You can choose to limit the observations to the given extent, but since we already did that in the web map, we'll leave that off for the purposes of this demo. If there's other widgets you wanted to add, if you want to put different types of bar charts or something that kind of shows the volume of data, you could do that. But within the widget itself, you see it makes the controls very easy to kind of start and stop these individual components or clear the previous observations. So very quickly, in just a few seconds, we're able to go from a stream layer that was published into a web map, and then in through a web app through the web app builder. And then you can expose those controls to your end users if they want to start and stop the feeds, or if they want to just clear previous observations as well. So one of the, as I mentioned, one of the kind of the chief limitations of a stream service, a stream layer in a traditional kind of, web map, is some of the limits that you have to the types of renderers. You only have basically a single renderer per layer. However, if you're using Pro 2.2 or newer, there's additional support for stream layers. You can come in and you can add these stream layers into a new portal map. Pro, I apologize, a new Pro map. And you can pull this either as create a new either portal or ArcGIS online item. You can find your stream layer from a stream connection, server connection, or you can add that data from path. Now, if you go this route of bringing the stream layers into Pro, you actually have a lot more control over the renderers. So yes, you could still choose to do a single symbol, but you can also do unique values. So if in this case, you can kind of see in the example to the right, if we had different types of kind of shipping containers, different types of vessels, we could use one color symbol for cargo vessels, another one for passengers, a different one for pilots, and a different one for tankers. You have the control just like you would for feature layers, where you can pick the different types of symbology. These can be, either different color variants. They could be totally different symbols for each one's unique symbols. You can also do kind of the graduated symbols. So if you want to do class breaks, you can put that in there as well. And you can also do different symbology for your current observations than from your previous observations. And just like we did within the web map, where we could change things like the rotation and the size and transparency, you can actually get even more granular by making certain observations, certain features render one way with one set of transparency, and another feature display with a different transparency, different colors, and different sizes. So we'll take a look at this in Pro as well, so you can kind of see what that looks like using some of the same data sets we're working with. So we're going to start with kind of taking that same flight stream and add that to the current map. And again, we can see the same dots that start to draw on the map. We can go into the appearance ribbon at the top. We can choose to define the symbology. We could also go into labeling if we wanted to set labels that drew alongside the points. You could kind of, just like you would with any other kind of feature, you can define the offsets for those labels. You can also view attributes of the features coming in, but in order to do that, you have to stop the feed temporarily, just so you can kind of, see kind of sampling of what the data has come through. This is really helpful as you start to plan what kind of symbology you'd want to use, because you can actually kind of, look at the data that's come through and see the different types of categories, how you'd want to symbolize the different styles. In this case, we can look at the different types of aircraft type, because this is flight data that we'd want to use. When you're ready, you can kind of clear previous observations and restart it. And as you can kind of see, we can no longer see that data at the bottom, because it even tells you again you need to stop the streaming in order to kind of view that current record. Now, if you had multiple layers coming through, you could kind of jump between the different tables, or if you're done with that, you can just choose to close out that component. So what we're going to do now is we're going to change the symbology of those points to something a little more beneficial, give us a little more insight into the types of data. Again, we could choose to do simple kind of single symbols, or we can pick unique values for the different renderers. If we wanted to do single symbol, it would be just like we did within the web map. You can come in and kind of pick the symbol you want. You can pick something for planes. And you can see those drawing. Now you also see there's a mix of some symbols on the map here are planes and some are blue dots. Those blue dots are actually previous observations. So we'd want to come in and define kind of different symbology for the previous observations in order to get those kind of changing. Just like we could on the web map, We can come in and change the rotation based on a heading value. So you can see when we do that, the orientation of those kind of plane symbols are now rotated. You can also come in and set transparency based on other attributes to kind of give you even more insight. So we could set transparency based on altitude. So you could potentially have those planes that were at a higher altitude showing as, as darker, and those that are lower to the ground as, more transparent. So you can kind of see in real time when you have kind of two vehicles, kind of overlapping, kind of gives you a good insight into some kind of height differences there. You can also choose to do unique symbology. So we can come in and as we looked at earlier, the different kind of flight categories, we can come in and pick that from our list of available fields. Aircraft category, I should say. And you can see we actually have 5 different types of aircraft that are coming in here. So we have jets and pistons, turbos, and others, and then somewhere where it's not available. So technically, I guess it's 4 kinds. We can come in and choose to pick different icons for each one, or we can choose to just kind of selectively define the different classes as we want. And just like we did with single symbols, we can come in and set our rotations. So you can get a little more insight into what's coming through. And now the great thing is you can come in here, you can get really granular with how you can control your stream layers if you're going through Pro. But the best thing is once you've set all of this within Pro, you can choose to publish this as a new web map, and all of the symbology that you defined in Pro will get carried over into your web map and into your web application. So even though, as we mentioned, stream layers do have some limitations, if you're using Pro as your kind of your starting point for developing all of this content, those limitations are no longer present because you can create it in Pro and then share it out as a web map, and you can have kind of the full granular control over those layers. So we're going to shift gears for a moment, and we're going to talk a little bit about kind of visualizing features. So we, kind of shifting from streams over to features for a moment. And for that, I'm going to hand it over to Qingying, who's going to be kind of talking on this point.
Okay, thanks, Josh. Okay, so next we'll discuss about various and unique visualization capabilities using data from Spatiotemporal Big Data Store. So as any regular map, you can view data and view the raw data, identify features, and view their attribute. So as we're dealing with a large volume real-time data, as more data coming in, there could be too many data on your map. It's very difficult to view them. So we enhance the standard map service with the on-the-fly aggregation. So what that means is when the number of features on your map is beyond a certain feature threshold, it will automatically switch over to the aggregation view, as the left screenshot shows. The feature threshold is something you can configure when you publish the map service. You can also update the value later on by updating the map service. In aggregation view, when you pan or zoom, the aggregation will get recalculated on the fly automatically. As you can see here on each aggregation bin, you can either show the number of feature count in that bin. You can also set statistics based on the feature on that bin. For example, average temperature. Also, as you can see, the either in the aggregation view or raw feature view as a middle and the right screenshot is allow you to access underlying data. Once you click on the map, it will return the features within the tolerance of that mouse click. If there are multiple feature return, you can using the button to navigate to inspect each individual feature. If your data content also time information, you can also use time slider to replay historical observations. That allows you to review how the data changes over time. So combining all these visualization capabilities, so those enable you to query and display data on any combination of time, space, and attribute. So next, we're going to give a demo to see how the aggregation works. Thanks, Josh. Okay, so what we're looking at right now is bus data around the Chicago area. As you can see right now, is the data was provided by Chicago Transit Authority, and as you can see right now, the number in each bin is automatically updated around every 6 seconds. This is because we set the map refresh interval. So as the real-time data come in, the data will get updated automatically. The data actually is, we use a read a CSV file, then we query data every couple of seconds and write data through GeoEvent to Spatiotemporal Big Data Store, then publish the map service. As you can see, if I zoom in, you can see how the data get re-aggregated to the appropriate, according to the map scale. I can pan and zoom in. If I zoom in really close, it will start showing the row features. Yeah, so this is, as I mentioned before, this is because I set the feature threshold on this map service. I think I set it to 500. So when I zoom out, there will be more features on the map. So it's beyond 500 features, it will show the aggregation view. So when I zoom in, there will be less feature on the map. So it starts showing the row feature view. In either aggregation view or row feature view, I can set up the filter. For example, I'll select, for example, route number, say 60. Yeah, 60. I'll apply filter. I can zoom out to see all. You can see right now it's only show the bus route 60. If I zoom in, I'll zoom in. See if I'm able to. Yeah, I'm able to identify features. Here it shows 90 return features. I can navigate to see the attribute, how the attribute changes. The same thing if I zoom in, if I zoom in close enough, it will show the individual features. And I can also, yeah, it starts showing the attribute. Okay, I think that's about this demo. So next, we'll show the different aggregation styles. Okay, so first we support geohash aggregation. The unique thing about geohash is it's only support WGS 84 and with 12 level of details. And as later on we'll show a demo, you will see at the higher latitude, some place the aggregation could a little bit distorted or stretched. We also support the square aggregation. So square aggregation would be anywhere on the map, you will see that it's not distorted. Yeah. We also support pointy and flat triangle. We didn't see many users actually using the triangle aggregation style, but that they provide the base for hexagon aggregation. Here's the pointy hexagon and the flat hexagon aggregation style. For square and triangle and hexagon aggregation, you can set the spatial reference and the level of details if you like. For each aggregation style we support, we actually create a spatial index for that particular aggregation style. When you write data into Spatiotemporal Big Data Store, the index is updated continuously. And we also add temporal index on the time field. And for each attribute field, we also create an inverted index that allows you to query and display data in any combination of time, space, and attribute. So far we covered point aggregation. We also support polyline and polygon aggregation. This one is actually as a square aggregation based on polygon feature. Yeah, for polygon and polyline, the aggregation is calculated based on the centroid of each feature. Here you can see as we zoom in, it shows the polygon features. Okay, so next we're going to give the demo to see how the different aggregation works. Okay, here, so what we're looking at is weather station data provided by NOAA. As you can see right now, we're using the GeoHash style. As you can see here, it's a little bit stretched out for the GeoHash style. We can also see how other different aggregation style looks like. So if I choose a square, so you can see that's the square aggregation. I can zoom in. What's the question?
So the question was, what do these numbers represent? So these values are actually the count of observations that were in each of those bins. So these bins, instead of showing, like some of these, there's a bin here that has 451. So instead of having 451 dots, which once they're stacked on top of each other, you won't actually be able to tell if it's one dot or 1,000 dots. The bins show you the count of observations or records that are within that defined area. And these are dynamically drawn, so as at different scales, those sizes of those bins change, those counts change. There's also a color ramp changes. So you see the areas that have a darker red, in this case, have higher volumes of observations in that area versus those that are kind of clear or kind of almost a white, have smaller numbers. As Qingying kind of pans and zoom around the map, you'll see those areas that those colors are actually getting updated on the fly, so that you might be moving into an area with a lower concentration or higher concentration and the brighter colors. So just to show real quick, and then you can come back to the demo. If you zoom up somewhere up here in like kind of Canada, where there's maybe fewer stations, kind of zoom in. If you notice now everything's shifted to red because it's all within the given extent. The areas with higher concentrations have the darker colors now.
Thanks. Okay, so right now we're showing the square aggregation. We can also, let's see how the flat triangle looks like. It's a flat triangle. So yeah, this is a flat triangle, and we can also show pointy triangle. That's a pointy triangle, and we can also see pointy hexagon. So just here, like the point. If it's a flat hexagon, it will show here it's like a flat. Yeah. Okay, so Josh just mentioned the value in each bin. Right now we set to feature count. Actually, you can also change to statistics. For example, so here, if I choose a statistics, I can see I like to use, for example, temperature. This all the field value available for this data, so you can pick any value, any field you feel you're interested in. Here I can say I like to choose average temperature, and you can see the value change here, like a minus something. To make it more interesting, you can also say I like to change the color. For example, I like to use the blue color for the lower temperature. And also you can say, okay, you can change the label, for example. You can see I'm not really interested in the decimal. You can remove that as well. You can make maybe the text different. Okay, so right now it's updated without the decimal. And also you can see right now the style is grid. I can change to oval. I can also change the size. For example, for lower temperature, I may want to get a smaller size, say 30. So that now you can see with the lower temperature, I got the smaller, different size. So if I move to the south, you can see their higher temperature. So this shows that using the same underlying data, if you choose different statistics, you can see the map can tell you a different story. I can also like say right now, I say the feature threshold, I set to 100. If I zoom in really close, it will show the row features. Okay, I can actually change, start to show row features. I can make this number a little larger so it can show more.
Zoom out.
So here I use a circle for the row feature the rendering. I can actually change that to, for example, I'll using the pointer. It starts showing the pointer. I can also say I like to rotate this symbol based on, for example, based on the wind direction. So you can see there's some, this is like, there are many weather station data on top of each other. If I see here, okay. And you can see the different direction. As we're dealing with real-time data, you can also enable time replay here. So I can come here, say replay. I can change to maybe replay every couple of hours. See, you can replace replay either in the row feature view or in the aggregation view. You can, that's tell the historical data, how it changed over time.
GeoEvent Server.
Okay. Okay, that's one thing I'd like to mention. This app is you can download from GitHub. We have the link in the next slide. Actually, all these options are available when you publish the map service from GeoEvent. Last thing I'd like to show is the GeoEvent. This is GeoEvent Manager. If you go to site, and you go to a Spatiotemporal Big Data Store, all the map service and feature service published listed here. You can, if you like to say you like to update the map service, for example, I like to change the feature threshold, for example, Right now I have 500. If you want to change like a 10,000, you can change here. The aggregation style, you can also change from here. Here's also copy pattern. You can copy the existing map service and create a new one. What this can be used for is, for example, you have the same underlying data source, but you like to have two different data representation. For example, I like to have one map service display the feature count, but another one I like to show the average temperature. Then you can have two map service for the same data set. And for the feature service, the same thing. You can have you can edit and you can also copy. I think that's all what I like to show. I'll switch back to Josh.
All right, thank you very much. So one thing I wanted to add onto that demo is, as Qingying was mentioning, what she was just exploring through there, these are all options that can be defined on the map service when you publish it. It's basically, it's important to understand when you're using the Spatiotemporal Big Data Store, the data itself is separate from the map and the feature services. So you can continuously write data with no map service, no feature service, because it's all written through the back end. You can then publish multiple map services with different symbology, different styling. The application we were showing is a very lightweight app. It's available here on GitHub. Or you can just search for the aggregation viewer, or you can go Esri aggregation viewer server map service. I'm sorry, it's such a long name, but it's just a lightweight thing. It's just basically an index HTML file, and you can drop it on a lightweight web server, and then you can point it to a spatiotemporal feature service, and you can go in there and do all of the changes, map server, and you can go in and make all of the changes that Qingying was saying. That application is great for kind of exploring those options. You can really kind of get a lot of insight just kind of switching some of those things around. In particular, that data set that we were looking at a moment ago was weather station data. And being able to tell that there were 100 updates from this particular weather station, that's not particularly useful. I mean, you don't really care, the station hasn't moved. It's just basically a sensor. If it updates 100 times or 1,000 times, that's not useful. What's useful is making some insight, some sort of averages or some sort of statistical value, the max, the min, some sort of deviation. You can run all that against the data that's actually within those bins. So that's why in that example, we switched from showing counts into temperature, because by showing temperature, that's actually much more useful information to say what's the average. And those numbers, those statistics will vary based on the time window you're looking at. Yes? So the question was, do you need GeoServer? Did you mean GeoEvent Server? Okay, I was making sure, yeah. Do you need GeoEvent Server in order to consume or view this? So we have right now, we currently have two products that can write data to the Spatiotemporal Big Data Store. That's the GeoEvent Server and GeoAnalytics. Either of those two products can create data in the Spatiotemporal Data Store. We will have a new one coming out that was mentioned in the plenary this morning. Tracker is also using this data store. Any one of those applications, those three right now, that use this data store, you can use this lightweight application to explore some of that. In order to actually get in there and apply those settings to your layer, you will need to use the GeoEvent Server because that's right now where all the interface is for controlling the visualization of those kind of map and feature layers. But that's just kind of the way where the interface for that is. So it's kind of a yes and a no. You don't need it, but you do need it if you want to, to actually put them into production. But you can get the app. It's just it's open to everyone on GitHub just to explore it, and kind of go from there. There's some other stuff on this page I want to kind of highlight for folks that are using stream layers. We do have some help on kind of the API for that, both for the kind of 4x and 3x. JavaScript, so you can kind of take a look at some of the changes that were added, kind of the newer release, some of the new functionality, particularly some of those new layers, rendering control like you see within new versions of Pro. We also have tutorials on using GeoEvent Server, so if you're just getting started with GeoEvent, you're wanting to know a little bit more kind of about the technology, that's a great place to start. We do also have a pretty active community on GeoNet, so if you're wanting to learn a little bit more about the technology, there's a button there you can subscribe and get updates, kind of new blogs. There's a lot of new stuff coming that will be coming between now and the user conference for GeoEvent Server that's going to be kind of posted out through GeoNet. In particular, there's going to be kind of 3 new video series that are going to be coming out. The first is all about kind of GeoEvent fundamentals. So for folks looking to just really get started and they want to say, how do I publish my first service? And, how do I create an input? How do I create an output? How do I, control some of these visualizations? We have a video series on that. That's fundamentals. We have a second series, which is going to be kind of the little nitty-gritty detail stuff, a lot of the same stuff that we cover in our best practices sessions, kind of tuning settings, kind of really kind of one-off topics. That'll be in kind of our tips and tricks series. And we have a third series, which I think is probably the most exciting, which is all going to be about workflows. So it's all about kind of solving real-world problems using some of these different tools. Particularly, we're getting into some of the analytics, some of the processing, where you might need to string together within GeoEvent Server several different types of analysis tools together to solve a specific problem. I have data that looks like this. What can I do with it? And it takes you the whole step from consuming the data, doing the processing, to visualizing it. So I say, please look out for that. We do have, we're just kind of scratched the surface for the real-time track this week here at Dev Summit. We did have our intro session just earlier today in the Learning Center. Of course, we're in the second session now, visualizing. We do have immediately following this session over in the Smoke Tree conference rooms, we have a session all about applying real-time analytics. So it's less on the visualizing and more about what you can do within the product, within GeoEvent Server, to do that kind of real-time analysis. There's some new processors that are added at the 10.7 release that's coming out the end of this month. You can kind of see a sneak peek of what some of those do, some new functionality that wasn't there previously. Tomorrow we have a session on best practices. This is an advanced session for GeoEvent Server. It's really geared towards users that are already kind of familiar with the product to some extent and want to get into some little more tuning, a little more kind of refining of the workflows, some best practices for different architecture planning and things like that. We do have a session on extending functionality of GeoEvent Server through our SDK. So we have 2 of our developers that are going to be presenting on building custom connectors, custom processors tomorrow. And then on Thursday, we have a road ahead session, kind of show what we're doing for kind of the future of GeoEvent Server. Also a new offering that's going to be coming to ArcGIS Online at kind of Q4 this year, which is going to be called Analytics for IoT, which takes a lot of the functionality that we have for our on-premises GeoEvent and exposes it out through ArcGIS Online. So we're going to be really excited about that. It's going to kind of really simplify the workflows for a lot of folks. It's all being run as software as a service. So we're really excited about that. You can kind of see a sneak peek of that on Thursday as well. We do ask that you please, like all the sessions, please ask that you take the survey. Every presenter here does receive the feedback directly from these surveys, and it is read. So we kind of help us understand, what went well, what didn't work well. If there were topics we didn't present on or something we talked too much about, please let us know. It really helps us kind of plan for each conference we go to. But with that, I would like to kind of open it up for other questions. I know we had a couple during the session, but yes. So the question was, in the bus kind of demo, what did those numbers show?
It's the feature count in each bin. Yeah, that's the default, unless you...
So some of that data is captured over time. So it could be that, one particular bus has gone, it's over, that's about 3 million observations. Mm-hmm. That was, I think, I think 2 months worth of data in there. So you could go back and replay it and just see like, okay, this bus has stopped here 20 times today. But each day it's going to increase as it's kind of going over that route. As Qingying showed, you can put a filter in place to select for an individual track, an individual vehicle or something, and go back and just look at that from the full aggregation view. You could further get granular and put some time restrictions to say, I only want ones from today. But you could also put information like if there were details about, like from the vehicles, maybe there was speed information from vehicles, you could do an average speed and switch to statistics or max speed. So you could say, okay, what's the max speed all my drivers were going? Where in the city were they speeding? And so that kind of stuff. There's a lot of insight you can get just from switching the visualizations around with the same underlying data. Other questions? Okay, well, great. Well, we're going to hang out here for a couple minutes. Please feel free to come up if you have other questions. Thanks a lot.
Thank you.